Here in problem number 12, we're asked to find the aromatic rings, and what it's asking for here are the individual aromatic rings. These are all a fused ring system here. We have 5 total rings here, but only this one and this one are going to be the aromatic ones. This one we can see is clearly benzene, pretty straightforward, but this one is not as straightforward here. We have the equivalent of pyrrole built into this fused ring. We can see a pi bond here, 2 sp2 carbons. This nitrogen conforms to an sp2 even though it has 4 groups because it is by another sp2 atom over here. And then with resonance over here, we've got a pi bond right there that would count towards Huckel's rule right here, 4n plus 2. So this is a aromatic ring, and this one here. The others have sp3, sp3, all sp3 atoms in here, so that one is not going to be an aromatic ring. So 2 is the answer on that. Next problem here is the carbon-13. Carbon-13 NMR spectroscopy. It's asking basically for the expected number of signals here. So on these problems we look for symmetry. Right here we have symmetry, down the middle of this. So this half is equivalent to that half over there. We've got the 1, 2, 3, 4, 5 carbon atoms there that are unique. Here we have a little more symmetry. You can see I've outlined down the middle of those methyl groups and right down the center of the benzene ring. And so we only have 3 signals with this one, 1, 2, and then all of the atoms here are 1 signal in the ring here, 3. That side is equivalent to that side there. Here, these are all unique in here. There's no symmetry in this thing, so we've got 5 total. A little bit of symmetry down the middle of this nitrogen and benzene ring here, 1, 2, 3, 4 for that one. You see that? So you see D is the answer. IR problems, a little more reasoning goes into these IR problems. First off, here we look at the numbers I've outlined that will not be on the ACS test. Remember, you have to kind of pick out the peaks yourself on the ACS, but here we have 3,000 and we have some peaks above 3,000 in here. That is the sp2 carbon to hydrogen bond right there. We also have sp3 carbon to hydrogen below 3,000. And then we do have benzene in here indicated with this. Those were peaks I had pointed out there in class that don't really appear on the chart, but there's something to look for in terms of its location. Just above 1600 on that, there's a series of 3 to 4 peaks right there. In this case, 4 peaks. And also, here are the numbers to memorize for benzene. About 1600 and 1500, we're going to have peaks for that. So you can see D is the answer with that. Some reasoning. The 2900 right here would eliminate C here, especially because we have no sp3 present in that. We also can eliminate B because there's the absence of this carbonyl peak right here. That should be around 1700, and there's nothing in here at 1700. And then here, this is usually around 1650 for that one there, and there is not that. Plus, this is indicating this is benzene and not just a simple alkene.